Are we clear with this?
Yes, sir.
Okay, bond length and the bond strength. Bond length is the distance between the two nuclei of the two atoms that are covalently bonded together. This is the bond length actually. Okay? If this bond length is short, the bond is strong, and vice versa. If it's a double bond, bond length is short. If it's a triple bond, bond length is short. So when you're comparing a single, double and triple bond is the shortest, double bond is the second, and then single bond is coming after that. Triple bond is the shortest. Triple bond is the shortest. Short, then double bond, and then single bond. Bond length. And energy needed, more energy and less energy. Okay, are we clear with this part? Okay, so let us move towards this tabulated data and see the information. What is the information there in this tabulated data? If you see, there is a table given there full of information. We have bond length, single covalent bond, single covalent bond, single covalent bond. Now when you move down the group of the halogens, it's Cl2, Br2 and then I2. Look at the bond length. Bond length is increasing. So there's an increase in bond length. Okay? And if the bond length is increasing, the amount of energy which is needed to break the bond is less. So the strength is less strong. Right? Less amount of energy is needed for that. What's the reason for it? Chloride is small and iodide is bigger. When you go down the group, the atoms and even the molecules are getting bigger in size. So the distance between the nuclei is increasing, and that is mainly depending on the radius. The greater the radius, the greater will be the bond length actually. Now look into the second phase, and the second phase is about carbon single bond, carbon double bond and triple bond. You can see the bond length, it's decreasing the way I told you. There's a decrease in the bond length. And what will happen to the amount of energy if the bond length is decreasing? In this case it's decreasing, so the amount of energy needed will increase. Okay, bond strength is increasing. The stronger the bond, the more is the amount of energy needed. So what is the conclusion? More bond length needs less energy, and they are inversely proportional. Okay, single bond and double and triple, that's the sequence. The bond length is increasing the way it's mentioned here. So the bond length here is increasing, the amount of energy in this case the bond length is decreasing, okay, not increasing. Reverse, triple bond, yeah. So triple bond, it will be go like this. So the amount of energy needed is basically less when you are moving towards the more bond length. So double bond is single bond is having more bond length as compared to double bond and as compared to triple bond. But when you go down, like from single to double to triple, the bond length is decreasing and the amount of energy will be increasing actually. Take a break of just 5 minutes, then we'll continue. Okay, just take a break of 5 minutes.